Okay, students, welcome back. We are wrapping up the lesson on diluting concentrations, and we are going to be looking at allegation alternate. We looked at allegation medial before, and now we are going to close off with allegation alternate. It is hoped that at the end of this lecture, you should be able to calculate the amounts of diluent and/or active ingredients needed to prepare a preparation requested at a particular concentration using the concept of allegation alternate with 100% accuracy and without assistance. If you want to dilute any mixture, or I should say, if you want to adjust any mixture, whether it be dilution or fortification, meaning to make it more concentrated, you have different mathematical concepts that we normally use. We're focusing now on dilution of mixtures. We will not be doing fortification in this lesson, but just to say that we looked at ratio and proportion calculations, we looked also at CSVS equation method, and we also looked at allegation medial. So now we're going to be focusing on allegation alternate. Allegation alternate is a mathematical method where the number of parts of two or more components or mixtures, when mixed together, are used to prepare a product of the desired strength and quantity. It must be noted, though, that the proportion of these components or mixtures are not known and they must be determined. So we're going to start with an example as usual. Calculate the amount of a 20% zinc oxide ointment with 14% zinc oxide ointment required to produce 60 grams of 16% weight in weight of a zinc oxide ointment. We have to look at this question, and I want to camp out on this question, the wording of the question, because this is what some students have a challenge with. The question is essentially saying, I have two mixtures, a 20% zinc oxide ointment and a 14% zinc oxide ointment. I want to mix these two ointments together in order for me to get a 16% concentration of an ointment of an amount of 60 grams. Okay? So you know the concentration of your final product as well as the amount, but you don't know how much of individual components or mixtures to use to get that amount that you require. Okay? And it is in these cases that we use allegation alternate. Allegation medial is the opposite. You would know the amounts of the components or mixtures and their concentration, but you don't know the final amount. You'd have to derive that, and you don't know the final concentration of the resulting mixture upon mixing these components. So there's a difference in the application of allegation alternate and allegation medial, and I don't want you to get them mixed up. So the first step is to identify the concentration and amount of final product to be made. We have identified that, and that is we need 60 grams of a zinc ointment of concentration 16%. The next step is to identify the concentration of the components or mixtures that are available to prepare the product. We have identified that there are two mixtures. One is a 20% ointment and the other is a 14% ointment. Therefore, we are going to have to determine what amount of the 20% ointment and what amount of the 14% ointment I need to mix together in order for me to get my 16% ointment of a quantity of 60 grams. The next step is now to calculate the proportion of the parts of each of these components. Now, this is the way how this arithmetic method is done, and I want us to pay very close attention to the steps. All right. So the first thing we have to do is determine what is the final percentage that I need in my product, which is 16. So we write the 16 there. The next thing is to identify the ingredients or the concentrations of the ingredients that we'll be using. We'll be using a 20% stock, and we'll also be using a 14% stock. I just like to point out here, and I know I'm going to say it further down in the lecture, but when you are preparing a particular concentration of a product from two or more other mixtures, you must, and this is something very important, you must have a concentration that is higher than the concentration that you're requesting to be made, and you must have a concentration that's lower than the concentration that you want to make. So for example, I'm making the 16%. I cannot have two mixtures of a 20% and a 30% to mix together to make 16. Those mixtures are way too concentrated, and you are going to have to dilute them in order to get the 16. Similarly, if I have two concentrations that are lower than the 16, say 14% and 10, I will never, no matter how hard I try, I will never get 16% because the 14 and the 10% are just too low when I mix them together to get 16. But you'll say, but Miss Price, if I add the 14 and the 10, I'll get 24. It doesn't work that way. Because essentially, when you're mixing the 14 and the 10% together, both of the mixtures are essentially diluting themselves. So you won't end up with a 14 or a 10%. As a matter of fact, you're going to end up with something much more dilute, right? So you probably end up with something that is a little bit more concentrated than 10%, but definitely less concentrated than 14. So you'll never reach the 16%. So we write down those numbers and then pay attention to this now. We want to determine how much of the 14 and 20% we need. The first thing we do is to move diagonally from the 14% to the 16%, and we're going to subtract those percentages. So we're going to subtract 14 from 16, and we're going to end up with two parts. Similarly, 20%, you run it diagonally. That means you're going to subtract 16 from 20% to get four parts. So let's go again. You write the 16 in the middle, have the 20% at the top, 14% here, and then you're going to move diagonally, which means that I'm going to subtract 14 from 16 to get two parts here. And you must write it here. It's very important that you follow the directions precisely. And here I'm going to go diagonally again with the 20%. It means I'm going to do a subtraction between these two percentages to get a number or a number of parts, which is 4. So what does this mean? It means that I will be able to determine the number of parts for the 20% and the number of parts for the 14% that I need to mix to end up with my 16%. How do I do that? You now go horizontally. So you move from here to here, and this is telling us that I'm going to use two parts of the 20% stock. Similarly, for the 14%, you go horizontally straight across to here, and it means that I'm going to use all of 4 parts of the 14%. So let's go again. I write the 16 in the middle, write the 20 here, 14 here. I go across to do a subtraction, and you're also always going to get an absolute number, not a negative number. So even if this is 16 and this is 14, you subtract to see what the difference in the percentages are, and you get 2 parts. Here, you do a subtraction between the 16 and the 20, and you're going to get 4 parts. How you interpret this is to say that I will be using 2 parts of the 20% ointment and 4 parts of the 14% ointment. You then add the parts together, and then you will end up with a total of 6 parts. So what does this mean? You now need to convert those parts to actual values, because you need to determine now what does 2 parts of 20% zinc oxide look like, and what does the 4 parts of the 14% look like. So in order to do that, we need to make some statements. The total parts is 2 parts of the 14% and 4 parts of the 20%, all added up to 6 parts. This 6 parts represents or is equal to or is equivalent to the total amount of the preparation you need to make. So 60 grams will represent the 6 parts. And of these 6 parts, 2 is going to be zinc oxide 20% and 4 zinc oxide 14%, excuse me, and 4 parts is going to be 20% of the ointment. That means 2 parts of the 60 gram is going to be zinc oxide 14%, and 4 parts of the 60 grams is going to be 20%. So if we make 6 parts equal to 60 grams, then we can do our calculation. We can now convert the parts to actual grams. So we're going to calculate the amounts of the 20% and the 14% zinc oxide ointments. So if 6 parts is equivalent to 60 grams of the preparation, then 2 parts of the 20% zinc oxide is equivalent to X grams of the preparation. So we do a little calculation, cross multiply. If 6 parts is equivalent to 60 grams, then 2 parts will be equivalent to X. And the 2 parts here will be 20 grams. You could also determine if 6 parts is equivalent to 60 grams, you could also determine what 1 part is. And once you know what the 1 part is, then you multiply by 2 for the 2 parts to get the number of grams for the 14%, and 4 times that 1 part that you would have gotten for the 20%. Similarly, if 6 parts is equivalent to 60 grams, then 4 parts of the 14% zinc oxide is equivalent to X, and that is going to give you 40 grams. So it simply means that I'm going to be weighing 20 grams of the zinc oxide ointment and 20 grams of the zinc oxide ointment, and this should be 40 grams of the 14% zinc oxide. So you ensure that all the parts contributed by each of the mixture adds up to the final amount requested. So amount of 20% zinc oxide contribution is 20 grams, and that of the 14% zinc oxide ointment contribution is 40 grams. So the total amount will be 20 plus 40 is equal to 60 grams, which was requested. So the new formula for the 16% weighting weight zinc oxide ointment would be zinc oxide ointment 20%, 20 grams, and zinc oxide ointment 14%, 40 grams. This is often used for semi-solids, but may also be used to be applied to liquids as well as powders. So let's see a liquid formulation as an example. Determine the amounts of 95% volume in volume alcohol solution and water needed to prepare 225 ml of a 70% volume in volume alcohol. Let's first camp out at the question itself, the wording of the question. It is essentially saying that I need to mix some amount of 95% alcohol, some amount of water together to make 225 ml of a concentration of 70%. So I know I want to make 70% 225 ml, and I need to make it with mixing 95% alcohol solution with water. First thing, identify the concentration and amount of the final product. We need 225 ml an alcohol solution that has a concentration of 70%. Identify the concentration of the components that we're going to be mixing, or the mixtures that we're going to be mixing. We're going to be mixing 95% alcohol solution and water. Note that the amount of or the proportion of these ingredients must be determined. So we're going to calculate the parts. Again, we want 70%. We have 95% alcohol and we have water. Now remember, we had said that if you're going to be preparing a concentration from mixtures, The mixtures must have, one must be greater than the concentration we desire, and the other concentration must be less than the concentration we desire. So let's make sure that this criteria or criterion is met. We have 95% alcohol, so that's good. So we put the 95% there. And then we have water. What percent would water have? Does water have alcohol in it? No. Water will not have any alcohol contained in it. So therefore, the percentage strength of alcohol in water would be, that's right, if you guessed 0, then that would have been the correct answer. So I want us to look at it, right? So similarly, in previous lectures, if we're using the pure ingredient, the concentration would be 100%. So if you're using a diluent like water, then the concentration of the active ingredient in water would have been 0. All right, so we're going to do our diagonal shenanigans. So we're going to do a subtraction between the two percentages here, 0 and 70, and that with 70 parts. And of course, 95 to 70, and that would be 25 parts. What does this mean? It means that I am going to have to use 70 parts of a 95% stock and mix it with 25 parts of a 0% stock, aka water. When I add both of these parts, I'm going to end up with 95 parts. This total number of parts is representing something. This is representing the amount of the ingredient or the amount of the product that you want to make, which is 225 mils. This is saying that 95 parts will represent 225 mils. It is at this point that you can determine what one part will represent in terms of mils, or you could go straight to it. You could go straight to saying, okay, what is the total amount of 95% alcohol? So if 95 parts is equivalent to 225 mils, then 70 parts would represent X mils, and that would have been 165.8 mils. And we know 70 parts is relating to the 95% alcohol, so we know that we are going to be measuring 165.8 mils of 95% alcohol solution. What about the water? If 95 parts is equivalent to 225 mils, then 25 parts will represent 59.8 mils of water. Okay, again, it's advisable to calculate the number of mils that would be representative for one part, and then you just simply multiply that by 70 parts to get the number of mils. So ensure all the parts that are contributed by each of the mixtures add up to your final volume. So if we are going to be mixing 165.8 mils of the 95% alcohol along with 59.2 mils, then we should end up with 225 mils thereabout, which is what we have. So the new formula for the 70% volume in volume alcohol solution that will be required, or the amount of ingredients that will be required to make 70% alcohol solution, would be 165.8 mils of the 95% alcohol solution and 59.2 mils of water. Mix them together and voila, you have your 225 mils 70% alcohol. Lots of mixtures used to prepare the product of known concentration and amount must have a concentration that is greater and lesser than the concentration requested. So you can't have two concentrations that are less than the requested concentration or more than the requested concentration. So one cannot mix 14%, I've said this before, with 10% ointment to get a 16%. It will not happen. you can use this method to mix 3 or even 4 lots of mixtures, right? But there's a particular way to do it. You can only do it 2 concentrations at a time, right? But you'll have to do them in steps. So let's look at this example. We could use example 1 and use lots of 14%, 10%, and 20% zinc oxide to produce a 16%. So let's see how that would go. So we're using 14, 10, and 20%. Again, what's the rule? The rule, let's go back. I'm sorry. The rule is that we are going to be using 14%, 10%, and 20% ointments to make the 16%, right? That's what is requested. And the rule is that we need to have a concentration that's more, a concentration that's less to obtain that. So we want 16%. So we're going to have to mix the 20% and the 10. We cannot mix the 14 and the 10. We'll never get 16. So we have to mix the 20 and the 10 to get the 16. We do our diagonal procedure. And here we will recognize that we need 6 parts of the 20% and 4 parts of the 10. What's left? We have the 14% ointment. Again, we need 16. We need to use the 20% and the 14. So notice that we are using one concentration that is greater than the 16 and one concentration that is less than the 16. You do your diagonal matching and subtraction, and then we would now have this scenario where you're using 2 parts of the 20% and 4 parts of the 14%. So what does this look like in real life? In real life, then, it means you're going to use 6 parts of 20% plus 4 parts of the 10% on this side. And on this side, you're going to be using 2 parts of the 20% and 4 parts of the 14%. What are you noticing? You're noticing that you're going to be using more parts of the 20% in comparison to the other mixtures. As a matter of fact, you're going to be using a total of 8 parts of the 20%. So let's see how this goes. So the total parts is going to be 16. Let's see how we can apply those. But before we go, I want to just reiterate that if you have 3 mixtures, 4 mixtures, whatever the amount of mixtures they are, you are going to have to do it 2 by 2. So you're going to have to take, if it's 3 mixtures, you're going to have to take the highest mixture and a lower mixture, mix those together, and then the same high concentration and another low concentration to get the concentration you want. And then you add them. So the proportions contributed by the 14%, the 10%, and the 20% ointments to obtain the 16 would be as follows. 14% of the zinc oxide is going to contribute 4 parts. 20% is going to contribute 6 parts plus 2 parts. And the zinc oxide is going to contribute 4 parts. So this 4 parts is for the 14% ointment. So that means you're going to be using 4 parts of the 14%. The 6 part is from the 20% as well as the 2 parts. And the 4 parts is going to come from the 10%. So let's see how this is applied. So this is applied now by adding all of these parts. And when we add all of these parts, I think we got 17. And then these proportion or these parts now, you're going to equate them in terms of grams. Now, the question didn't say how many grams of the 16% is needed. This is just showing you how you would use this mathematical method to combine 3 or more mixtures to produce a particular concentration. So just as how we used the other parts in the other question to determine the amount in terms of grams of each of the mixtures, you'll do the same thing here. So let's summarize. Allegation alternate can be used for both liquids and semi-solids such as creams and ointments. And the concept is applied when the proportions of 2 or more mixtures of known concentration needs to be determined to prepare a product of known concentration and amount. To use this concept, the concentration of each mixture must be greater and lesser than the concentration requested. So you can't have 2 concentrations that are greater than the concentration you want. So if we use the same example I've been using with these ointments, you want 16%, you can't use a 20 and a 30. If you are using 2 concentration less than the concentration you are requesting, you will never get it. So you can use 14 and 10 to get 16. You must have one that is greater and one that is less. And you can only do the calculation or the arithmetic method in batches of 2. So if you're using 3 mixtures, you have to pick out, you most likely are going to use the higher concentration twice. If it is that you have 2 concentrations that are greater than the concentration you're requesting and one that is less, then you're going to have to use one scenario, you're going to have to use the high concentration with the low, one of the high with the low, and one of the high with the low. So for example, if I have 20% zinc oxide, 30% zinc oxide, and a 10, I'm going to pair 20 and 10 and 30 and 10. Okay? All right, so I thank you so very much for your attention. Please, I do not want for you to feel dejected. It's new, but you need to practice. So I'm going to prepare 2 questions on these concepts on the required platform, and you're going to go through the lectures. I advise you to work in pairs, work on them together, and individually submit your answers. All right, thank you so very much, and enjoy the rest of your day.